Can you watch what? I would like for you to watch my screen and fill out yours, but I will try to post a video so that you can do that later if you want. Where is what? So everybody with me on slide 5? We're going to talk about trig. So trig only works with right triangles, and there's a little mnemonic, so, ka, toa. What that means is sine, I so desperately need a better stylus. Sine, that's the S of an angle, equals the ratio of the opposite side over the hypotenuse. And ka is cosine of an angle. That weird circle just means an angle. Is adjacent over hypotenuse. And then the third one, T, is tangent of the angle equals opposite over adjacent. But before we can do any of that, we need to know what the adjacent side is, what the hypotenuse is, and what the opposite, what the adjacent and what the hypotenuse are. So if you're standing on angle Y, the opposite side is literally on the opposite side of the triangle. So label that 3. Oh, I could open a pear deck. Would it be easier if I open a pear deck for you guys? Let's do that. I forgot I put these in pear deck. Say it again. Yeah, you're going to want to submit these by Monday. And let me put the pear deck link in the chat box so that you can do that. That'll make life easier. The last one should have been done by yesterday. This one is for Monday. Yeah. Boom. So now you have a pear deck link. It'll make it easier to write on. I'm going to go back to mine though. Okay. Does the pear deck link open? Hopefully, yes. Which side on slide 5, the 3, the 4, or the 5, is the hypotenuse? Which side of this triangle is the hypotenuse? Which one is opposite that right angle? Hypotenuse? Yes? Hypotenuse over here is also 5. The hypotenuse is never going to change. It's always going to be the same. So I've got a side that's the hypotenuse, a side that's the opposite, which leaves the last one is the adjacent. The adjacent is always the hardest one to see. Okay, it's like next to the angle you're talking about. But what if I switch and I look at the other triangle where a different angle is marked? Okay, the hypotenuse is still the same over here on the right side with the X. But if I look at this angle, the opposite side is the 4. So on the opposite side of the first one was a 3, and the opposite side of the second triangle is a 4. What's different? Why did it change? Did our angle change? We're talking about Y is the angle opposite the 3, and X is the opposite side of the 4. So our O, A, and H are going to change. Okay? I feel like I'm talking to myself today. The adjacent side is the one next door. So here, the A is adjacent. Okay. So we've got O, A, and H. Opposite is the O. Adjacent is the A. and hypotenuse is the h. So let's see what that means. If you go to slide 6, I've just given us one triangle. We're going to try to find x, okay? And over here on this side, this is the formulas to find sides. And these are the formulas to find angles. So we're going to use these. What's the O if I'm given x? If I'm trying to find x, what's the O? What's on the opposite side? Somebody say 4. Four. Yes, 4. What's the hypotenuse? 5. So put a 5 here. You need a calculator. So open Desmos. Ay, ay, ay. Desmos graphing calculator. And we're going to go back here. We're going to put this, that looks kind of crazy, sine -1, parentheses 4/5. We're going to put that into Desmos. Sine -1, 4/5. So we need to go sine -1, oops, and then parentheses 4 divided by 5. The problem is we need to go to this little wrench and put it in something called degree mode. Okay, you put it in degree mode. Then we come back over here, I've got 53 degrees. Okay. All of a sudden that math has told us, because what I put in the calculator was sine -1, 4/5. We're just taking the ratio of 4/5. And all of a sudden this is 53 degrees. Okay. No need to draw the triangle, no need to make the triangle out of something, no need to use a protractor. We just use the side lengths to find the degrees. We already know that this angle is what? 90 degrees. So how can we find y? Add 53 and 90 and see what adds to 180. So we can do 180 minus 53 minus 90 equals what? So again, either go to Desmos or grab a calculator. 180 minus 53 minus 90 equals 37. Beautiful. 37 degrees. We can also find that by doing that same sine thing. The opposite of this angle is 3, and the hypotenuse is still 5. So let's do sine, and when I'm looking for an angle, I always have to do that -1 of 3/5, because that is opposite. Oops, supposed to get an eraser. Opposite over hypotenuse. Okay, opposite over hypotenuse. So if I go back into my Desmo and I change this to 3/5, 3/5, look at that, 37 degrees, which is what we got right here. Okay, trig, it's an easier way. Okay, these are your formulas, sine, cosine, and tangent. Let's try another one. Let's test that 5, 12, 13 triangle. So do we want to find x first or y first? X, okay? So if I'm looking at x, let's use cosine this time, just for something different. I want the adjacent angle. So what's the adjacent angle to x? Or the adjacent side? 5. And what's the hypotenuse? 13. So in the calculator, we're going to do cosine -1 of 5/13. Okay, so we go over to our Desmo. This time, instead of putting sine in here, we do cosine. -1. And what were our numbers? 5 and 13. So that is 67.4 degrees, which was crazy close to that 70 degrees that we just talked about, right? So 68 degrees. So when you built your triangle yesterday and measured 70 degrees, that was spot on. Which angle is the 90-degree angle? What's it opposite? Where's the 90-degree angle? It's in the corner where the 5 and the 12 meet. And so what's angle Y? Do I have to measure it? Do I have to calculate it? We just got to subtract. Okay, 180 minus 90 minus 68 gives me what? 22. Awesome. You can absolutely do any of those. So let's go to the next slide and try a different one. We used cosine, we used sine at the beginning. So let's try tangent here and see if tangent works. So if I'm trying to find x, what's the O? It's hard for me to hear you, Mikhail. Can you type it in the chat? So the letters stand for sine, opposite, adjacent, and then hypotenuse. So the O is opposite. The A is adjacent. And the H is hypotenuse. And then sine, cosine, and tangent. So if we go back up to slide 5, we did opposite, hypotenuse, and adjacent. Opposite, hypotenuse, and adjacent. And I think we have some more slides down here that show that, but I'm not sure where they went. So let's see if tangent works. Okay. So what's the opposite side? I want the opposite, the O. Opposite is going to be the 12. And adjacent is going to be the 5. So here I would do tangent, -1. That's inverse tangent. And then O over H, 12 over 5. 12 over 5. If you're in Desmos, there's an easier way. If you come down here to the little keypad, you can go over to functions, and you've got all of your stuff right here. We're going to work with these 6, but no, there are 16 or however many of them that there are. So we're going to do inverse tangent. And you can just click on the button. Then you don't have to worry about how you find the negative. Make sure you're still in degree mode. That is super important. You don't do radians until math analysis. So degree mode is what we're going to stay in. And then let me refresh my memory. We want 12 over 5. So we're going to put in 12 over 5. 67 degrees. Okay. So trig is a shortcut. It's an easier way, and we're going to do some practical stuff with it too, but we need kind of a foundation first. So what about this triangle? What would we do here? What's the opposite, the adjacent, and the hypotenuse? So we got to pick an angle first. Do we want to work with X or Y? Let's work with Y this time. I like it. So what's the opposite side from the Y? 24. Go straight through the triangle. That's the opposite. What's the hypotenuse? 25. I've got a right angle up here. I know it's the right angle because it's opposite the longest side, which leaves 7 as the adjacent. So I've got opposite, hypotenuse, and adjacent, right? So do we want to use sine, cosine, or tangent? Let's use tangent, okay? So I've got tangent of -1, because I'm trying to find the angle, of the O, which is 24, over the A, which is 7. You have to use a calculator, absolutely. You don't have to use Desmos. You can use a TI-84 if you have one of these. You can also use your phone. So on my phone, I've got an Android, so iPhones look a little different. If you put it in portrait mode, you get like this. But if you put it in landscape mode, did it go? Then you've got the functions up here. So you definitely have it in your calculator. You can also download Desmos onto your phone. There's a whole bunch of calculator apps that have it. But Desmos is the easiest, and that's what you have on the SOL if you're going to take it, but nobody here needs to take it, so it's kind of a moot point. Tangent, I've already forgotten what my numbers are. I'm a little ADD today. 24 over 7. So we're going to do 24 over 7. So we get 73.7. So Y is 73.7 degrees. You can round, so it depends on, like in real life, it depends on what you're doing. I worked for a landscaping firm or not a landscaping firm, a surveying firm for a while. They got like super specific satellite degrees that use this trig stuff. So the satellites do the measuring and the calculating and then feed it into a computer. We did it down to the 10,000th of an inch. So that was 4 decimal places. But for most people, you can round to the nearest degree or, you know. So what would X be if we know Y? So angle Y is 73.7. Angle Y is 73.7. So what's X? What is it? 16.3 degrees. Perfect. Do we want to try another function just to make sure we've got it right? Let's try either sine or cosine. Which one you want to do? Okay, let's do cosine. And let's switch to X to see what that gives us. So I want the adjacent of X. Which side is adjacent to X? The 24. And which side is the hypotenuse? 25. That one never changes, which is always convenient. So if I do cosine of -1, inverse cosine, and I do A over H, that's 24 over 25. Go to my calculator. We can go down here into functions. I want cosine this time. Totally forgot what my numbers were. 24 over 25. 24 over 25. Sometimes it's important to close the parentheses and sometimes not so much. And I got 16.3. And when we subtract from 90, because this angle should be the complement, right? That would be 73.7. We get exactly the same numbers doing it a different way. So in the chat box, in slide number 4, somebody was asking, how do we get the numbers? So here yesterday, we made these triangles and we could put the angles in here, but we just did this one, right? So what did we just do? We did the 5, 13, 12 and got 68 and 22. So if we go back up here, we got 68 when we actually did the trig and 22. So those who measured, built and measured the 70 and the 20, that's fantastic. If we come down here to the one we just did, the 7, 24, 25, we got 16.3 and 73.7. 16.3. So was that this one? 16.3. Right? 7, 24, 25. Oh, I was putting it in the wrong spot. So basically, that's how you find the angles. Okay. Questions on that? Do we want to create a couple of extra ones just for practice?
Yeah.
Okay. Let's see. I think I have some practice in the next. Let's see. We can open this one. Well, let's go back to slide 4. Let's do this. So we had 73.7, right? So let's build this. What was 8, 15, and what's the side that goes in here? Is that 17?
Mm-hmm.
So let's just do that. If I've got an 8 and a 17 and a 15, then we'll put an x down here. What function do you want to use? Sine, cosine, or tangent? Okay, so sine is O over H. What's the O for x? 8. And what's the H for x? 15. Right? So for this one, we're going to do sine -1 and then 8 over 15. 8 over 15. So put that in your calculator and see what you get. How many degrees is that? When you put that in Desmos or put that in your calculator, what do you get? So we need to do inverse sine. And 8 over 15. Did you put in the inverse sine, I mean? And do you have it in degree mode? So if you have it in radians, you're going to get 0.56. Go up to the little wrench in the upper right corner of Desmos and switch it to degrees at the bottom. 32.2, absolutely. Yep. Did it switch to 32.2, I mean? So the small angle is going to be 32.2. So what's the big angle going to be? What's the relationship between those two angles? Going to add up to 90 degrees, right? So 180 minus 90 minus 32.2 gives me what? 67? 57.8. Awesome. So that was the third group. What about the fourth one? So first step would be to draw your triangle. Let's see if I can get a new color. So this was 9, 40, 41. Is that a 40?
Yeah.
Okay. So we can make, this time, let's look for this angle. So that's going to be the medium angle because it's opposite the medium side. So now this is the O. Let's do tangent. And what do I need for tangent? Opposite. So TOA, tangent, opposite, adjacent. So tangent of -1 is O over A. So I've got the O, that's the 40. And what's the A? 41 is always going to be the hypotenuse. So 9 is going to be the adjacent. And adjacent is the hardest one to see. It's not the opposite. It's not the hypotenuse. It's the other one. So we'll put a 9 in here. And then in my calculator, I just put tangent -1, 40 over 9. And what do you get? You are so fast. You beat me. 77.32. Yes, sir. 77.32. So what's the small angle? What should the small angle and the medium angle add up to? 12.68. 12.68. You killing it in the calculator today. So let's do one more. Do you want to do, what's the missing number for the 1161 triangle? What's the missing side length here? 11 what? 61. Is it 60? I don't know. It is 60. Look at you. Okay. Do we want to use sine, cosine, or tangent?
I didn't know which one to use.
With 3 sides, you can use any of them. That's a great question. I'm giving you enough information that you have all 3 sides. You can use any of them you want. Cosine. What do I need for cosine? So ca. So CAH. What goes in there? So ca TOA. So cosine has A and H. What do I need for A and H? Adjacent and hypotenuse. Hypotenuse is always the easy one. So that's going to be the longest side. And then adjacent, I've got to choose an angle. So let's choose this angle. Which one is the adjacent to the X? The 60. It's right next door. It's not opposite. It's right next door. So this is the H and this is the A. So do 60 over 61. Inverse cosine, 60 over 61. It is 10.38. So I know that's the small angle, 10.38. So how do I find the medium angle?
79.62.
89.62 or 79.62?
70.
Nice. Because these two angles should always add up to 90 degrees because this largest one is always 90 degrees. I think you guys have got it. I'm so impressed.